Welcome to PV Online Physics. We're going to take a look at a problem that deals with wave speed, wavelength, and frequency. In this example, we're looking at dolphins. Dolphins can make these really high-pitched sounds, and that's how they talk to one another. The highest frequency that they can produce is 1.5 times 10 to the fifth hertz. The speed of sound in seawater is 1,560 meters per second, and we want to find the wavelength of sound. Now you'll notice that the speed of sound is quite a bit more than the speed in air. In air it's 340 meters per second. So what that does is that allows the wave to go through the water faster, partly because since the water molecules are close to each other, it's easier to transmit that energy. So we've got our frequency, and the frequency is going to be in hertz, so that will always be the clue for you there. And we know that the speed of sound is 1,560 meters per second. And we're looking for the wavelength. What is the wavelength of this sound? Now we need to choose the appropriate equation for velocity, wavelength, and frequency. Well, you look at this and we know that we want the velocity, which is going to be in meters per second. Wavelength is in meters, and frequency is in hertz. And all a hertz is 1 over second. The equation that satisfies those requirements is this guy right here. Whoops, there you go. Now we have to choose the appropriate equation to rearrange it so that we can solve for our unknown. We're looking for the wavelength. We need to get rid of the frequency, so we're going to divide both sides by frequency. And the first equation is going to satisfy that. Now we just need to put the values into the equation. We substitute in our velocity and our frequency, and we're ready to go.
Choose the correct unit of measurement.
Okay, let's choose the correct unit. We want a wavelength. Just like the word suggests, it's a length. That means that the unit would be a meter. Now we have to put this in our calculator, and if you do so, excuse me, put 1,560 divided by 1.5 times 10 to the fifth. Now you get 0.0104 in your calculator, but you'll notice this is configured so that we put it in scientific notation. So in scientific notation, I'm going to put 1.0 instead of 1.04 because of significant figures, and the exponent would be to the negative second. So let's submit this, and there you go.